Hi, my name is Dania Medina, and today I'll be explaining a question from Chapter 2 of Management Information System. The question states, what is a binary data? Give an example of a binary data other than 0 and 1. So a binary data is an electrical signal inside a computer that commands the computer to do something, like write a word or a number. Every word we see on the computer and phone is represented by a 1 or a 0. Other examples of binary data other than 1 and 0 is true, false, yes, no, on, off, and so on. So how do you represent a word or even just a number with just zeros and ones? So first you would have to understand that there's a table which starts with 1, then it's 2, then 4, and then 8, 16, and so on. Basically you multiply each by 2. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So let's say I want to write the number 9. Well, I have to go down and see which number fits into 9. 16 fits into 9 0 times, so it will be 0. 8 fits into 9 1 time, so that will be a 1. 4 fits into, after you put a 1 here, you subtract 9 minus 8, which leaves you with the 1. So what goes into 1? 4 doesn't, so that's a 0. 2 doesn't, so that's a 0. 1 does, so that's a 1. And that's how you represent a 9. 0, 1, 0, 0, 1. Now, say you want to represent a word. Let's say the word is dog. Well, first you have to understand that each letter has a number. For example, A is 1, B is 2, 3 will be C, and then 4 will be D, and so on until you get to Z. So if I want to do dog, I would first have to figure out what number represents each word. So D is represented by 4. A, B, C, D, 4. O will be represented by 15. And G is represented by 7. So let's say, since each letter has its own number, you would have to do a binary data for each number or letter. So let's say I want to do D. Well, D is a 4. So if I draw out the table, 1, 2, 4, 8. Well, 4 goes into 8 0 times, so it's 0. 4 goes into 4 1 time. 4 minus 4 is 0, so that means the rest will be 0. And then, so D will be represented by 0, 1, 0, 0. Now say I want to do O. So the chart will be 1, 2, 4, 8. If I want to do O, which is represented by the number 15, I would have to subtract down or count down. So 8 does fit into 15 1 time, so that will be a 1. Now 15 minus 8 is 7, so 4 goes into 7 1 time. 7 minus 4 is 3. So that means 2 goes into 3 1 time. So there's only one left, the number 1 left, and 1 goes into 1 1 time. So that's how O is represented. 1 1 1 1. Now if I want to do G, which is a 7, I will draw the table 1, 2, 4, 8. Now keep in mind that if the number is larger than, let's say, 17, then you would have to draw 16 and then 32. But since the numbers are lower, I am only writing 1, 2, 4, and 8. So 8 goes into 7 0 times, or 7 goes into 8 0 times. And so 7 goes into 4 1 time. 7 minus 4 is 3. So there's the number 3 left. 2 goes into 3 1 time. So 3 goes into 2 1 time. So 3 minus 2 is 1. There's 1 left, so that means this is 1. And so this is how you represent binary data for the word dog. 0 1 0 0 for D, 1 1 1 1 for O, 0 1 1 1 for G. And that is how the computer processes information to create words and numbers.